Hey everyone, we should be on now. Thanks for joining us today on the February Functions webcast. I'm Chris.
And I'm Alex.
Today we're going to be talking about a couple different topics, including proxies, Azure Functions Pack, and a bit about our language workers. That'll be towards the end of the show. And then at the end of the show, we'll take your Q&A. So definitely feel free to keep on asking. We have a bunch of them that were already up on Twitter. We'll answer as many as we can until Oded drags us off the screen. So.
Cool. So yeah, I'm Alex Karcher. I'm one of the PMs on Azure Functions, and I'm going to talk to you guys today about Azure Function proxies. Hamid, one of our devs, was on a couple of months ago to talk about proxies at a more high-level overview, and I'm going to go through specifically some of the local tooling scenarios for a couple of different API development scenarios in Visual Studio. Woo! So yeah, if you want to switch over to my screen real quick, I have Visual Studio open with a new functions project with a proxy already configured in it. For everybody that doesn't know, function proxies is basically our API toolkit in Azure Functions. And we have awesome portal support and Visual Studio Code like functions runtime support, but you can also run proxies inside of Visual Studio. So in here, I have just a super simple mock API. This is kind of where you'd want to start if you were writing an API, just have some sample data back and forth. Something that's kind of interesting, in Visual Studio, you just add this proxies JSON file to get proxies to work. So I've added it in here. The schema lets you know how this file needs to be structured. So here, I'm going to rebuild this project. And then hit run, and I should be able to see this proxy running locally. So let's let it rebuild. I've found that with precompiled functions, you have to rebuild every time you change the proxies file, otherwise it won't change. If you're using not precompiled functions, everything works just fine.
Might be having a small AV glitch.
Oh man, what is missing from the final stream?
I don't know, I'm clicking on present everyone.
Oh, I see, okay.
And you're not seeing it?
Now is it my screen?
I can't debug this silently like I normally do because now I'm actually in front of the camera. But still no one else bothered to learn Google Hangouts. So
no, it's good. The last proxies demo didn't get shown on video, so I think at this point we've known that proxies breaks screen sharing.
So what's really great about the local experience as you kind of see it now?
Yeah, so to me, the coolest thing about this is that you don't have to go back to the cloud and redeploy your function every time you want to view a change.
Mm-hmm.
So I can run this locally. I know that I can isolate any sort of network variable in between me and the API, especially for API development. Like you can run into different CORS settings. You can run into different authentication settings. It's really awesome to be able to just plug directly into the functions runtime and like debug your code directly. I don't know how many people program from planes, but if you want to, you could demo this all completely offline. So I have the function running. You can see I have a local function and I have my proxy here. So I'm going to go into Postman. This is an still no video.
I'm clicking the button.
Do you think this will go? Do you think if
you're clicking on my screen now?
Is that your screen?
That's the screen you
Is this my screen?
Well, now we don't know which one is which. We're both looking.
I really think this is my screen.
Okay, that's your screen, yeah.
Do you think?
And that's presenting to everyone. You're fine, yeah.
Oded, is this my screen now? Yeah, okay. Huh?
Okay.
I think it is Chris's screen.
We should
it's just delayed. Yeah. Okay. Cool.
We should be back from the Matrix now.
Yeah. Woo. There we go. That looks way better. Okay, so real quick for everybody that couldn't see, we have a local function. It's in Visual Studio. I have a mock API here configured, as we can see, because there's no backend URI, just response overrides. I'm running it in the local functions runtime here. I get my URLs for both functions. And now I'm going to test this API in Postman. This is a really simple API. Well, it's a really simple mock API. It just returns gracias to every request. But I eventually want it to read in feedback, detect what language the feedback is in, and then thank that feedback in whatever the native language is of that feedback. But for the moment, I just want any API that does anything so that I can start coding against it. So that works really well. The next thing that I want to do with this is I want to point this at a local function. We actually demoed this. We demoed this already a couple of times. I don't think Hamid covered it, but I covered it in a Connect video. So actually, for the sake of time, I'll just blaze right past that. But I do have a simple function in here. I, in fact, want to call a function running on a different version of the function host. So to me, one of the coolest scenarios for proxies is calling a bunch of different functions all together under one API. If you had like a microservices architecture where you wanted all of your different services or even different versions of the same service running in different function apps, they would all have different URLs, and it would be very confusing to write code against that API, a different URL for like your post and get and set methods, or like a different URL altogether for version 1.1 as opposed to 1.2. So I'm going to change this around. I actually have my my function JSON all ready to go. I'm going to replace my mock URI or my mock response with a backend URI. And something that I think is really cool in app service or in functions altogether that you can leverage in proxies are these application settings. We've shown a bunch of demos of them in the cloud, but locally it's really cool to map variables that are different in your local environment than they are in the cloud. So I have this local function running that I'm just running out of Visual Studio Code in PowerShell. I have a local function with a proxy doing a very similar thing, but that is also deployed up to the cloud. And so I want to test locally against my entire local instance, and then when I deploy this to the cloud, I want this proxy to map to my cloud deployed version of this function.
The nice thing is it's not just local and Azure, but that can also be different stages on Azure. So you can have a pre-production site on Azure that's using those app settings as a way of overriding the values.
Yeah, and when you swap, the values will all change.
And we do the same thing for queues and storage.
Yeah, queues and storage and even app service altogether independent of functions. It's all over the place.
That's great.
So yeah, I'm going to rebuild this now with a different proxy. Something that's interesting to show while this is going, with this schema, we actually get inline comments for everything. So you can hover over any of these different proxy conditions and you can see the description of all of the different components. All right, so this succeeded, so I'm going to run this again. And now, when I call this local API, we should see here in PowerShell requests come through for this other function. So I'm going to go into Postman, and I'm just going to send the same request to the same endpoint. It's going to take a moment. It's thinking real hard. There we go. So it warmed up, executed, and I got back a different response, slightly different. This is thanks in Japanese, I do believe. Being translate would lead me to believe that this is thanks in Japanese. And if I go into the proxies JSON of this function, you can see it's a very similar mock API, just with thanks in a different language.
Unfortunately, Katie is in Amsterdam right now, so we can't have anyone fact check you.
Nope. Ha ha ha. It's my ultimate scheme. Okay, so I'm going to stop this, and then I'm going to deploy this up to Azure. You can deploy functions a bunch of different ways. You can use continuous integration through like GitHub or Visual Studio Team Services. I really like Visual Studio's just direct publish support. I've already made a profile in here. This is the same way you make profiles for app service apps. You just go into create new profile and it gives you a picker for all of your different resource types. So I'm going to publish this function up to Azure. It actually runs pretty quickly. I can go up here. I have the same function up, and I can just keep refreshing it until I see my new functionality come through. So I believe that, oh no, it's still spinning. Yeah, this is when you do that create new profile, it uses your different sign-in information to pull down all the right credentials to publish up to Azure. I think it's really nice as opposed to just keeping a file with all of your different credentials or some other store of all that information. Yeah, I go to Azure and I have the same function now in read-only mode, and I have the same proxy also in read-only mode. So I now can go into Postman and I am going to call that same API, but now up in Azure. I'm going to send it some feedback. It's going to take a moment to run the first time. Colby has a good blog post about this, if any of you guys have seen. So now it's calling a separate function on Azure that I've mapped to a different app setting to actually give me the correct information for this API. So Chris, do you happen to have a particular language that you would like to provide feedback in that's not Spanish?
Do you think it'll... What is my one side language that I know? Not sign language.
That is sign language.
German is fine. I took 5 years of that, so apparently I'm supposed to know it.
That's good. I'm going to be doing a presentation in Germany here in a couple of weeks, so that should be good to see.
My limited 5 phrases of German that I still actually remember from all that.
All right. So we now have some German feedback. I also like this because I just like showing different like character sets. I'm always surprised when all of the different character sets work, although I expect it to work. So yeah,
do you appreciate umlauts? Is that your thing?
I do appreciate umlauts tremendously. So yeah, German feedback has also been marshaled over to my gracias function, and then it gives me back German thanks.
Well, nice.
Okay.
Gracias for that great demo on proxies.
Yeah, no problem.
Okay, so the other parts of our agenda, I guess, are Func, and then we'll go into languages at the very end. Now that one's a hot one from Twitter. But I'm going to show you something much more boring, potentially. Hopefully it's not too boring. And we're going to talk about Func. Func is, we talked about that before on this particular webcast, but it is now, let me go ahead and just click over here onto releases. V1. So V1 essentially means that we promise we won't break you when you use this tool. That's essentially the feedback that we got. Hopefully it's actually presenting to everyone. Okay, there we go. Cool. So now with it being in V1, you can go ahead and trust to use this in any of your CI or tooling stories. It's a great way of, if you've got a large amount of JavaScript, to package it into a single file, which really helps to reduce cold start. So it's just one of those tools that it's just a single line command added to your publish step. It makes things simple as far as what you deploy. It goes ahead and actually removes any node modules you'd need to deploy normally. And this is nice because it's also then very immutable. Nothing can really change. You won't have to run npm install again once you've deployed up to the functions as well. So it really helps to make everything just a lot simpler. Before 1.0, though, we did add some features in 1.0 that we really think are going to help people have an easier time of things. And the nice thing is a lot of these things were added by the community. We had 2 PRs for some of the biggest features that are actually in this release. I'll just kind of talk over them briefly at a high level and then just kind of show you why they're useful in a quick demo. So the big features are we now have the watch option for Pack, and that'll go ahead and basically continue to watch your output when you're running. And I'm noticing here that I have a doc bug in the sense that we haven't updated this with the watch flag, but it does show up when you run a Func help. And then we have this copy to output flag, which allows you to basically, instead of having it Func and touch your original files, it'll go ahead and copy the important files over to your .func directory. And this allows you to just publish from your .func directory and not have to go through there and manually delete your node modules and then run func unpack and then npm install again to go ahead and edit. That was really kind of slow. We didn't like having to touch your source code in general as a build step. So we added that option. It's still opt-in because it's easier to not to do unpack as far as learning how this tool works. But the copy output flag really helps to make some things fast. And the other thing that was added by the community was the edit config, which allows you to specify a JavaScript file, and that's kind of defined right here, which will let you basically take in the config as we prepared it by default for Func and modify it. This means that you can break Func. If you do the wrong things in this config, you can potentially change a bunch of expectations. So you have to be careful what you do there, but that does mean that you can add additional plugins. Like in this case, it was to set global gently as false, just a flag which helps certain modules webpack properly. So this is mainly meant for just simple config changes as opposed to large changes to the way that it works. But with this, you can totally configure anything you want. We don't need to add 100 different flags to support these various options. And it's relatively clean. So thanks again for the various people in the community that have helped support and provide tests for these things especially. So just a quick demo. I've got John Papa's lovely Star Wars API for Azure Functions demo here. It's one of my favorite Node.js just API apps to show as an example. Got it here, just cloned it locally. And then I can go ahead and do func host start. And I've got myself my people API. If I go over here, I'm just going to go ahead and refresh, and we see we get back Luke Skywalker, original generation Luke Skywalker, right? So then what we want to do is if we look at the functions.json here, you see that it's not doing anything particular as far as specifying script file. And so this is just doing the normal thing where we'll read in your directory and then guess that because you have an index.js file, that you want to run the index.js file as your entry point. But this is just because it's our defaults. We're not being specific here. When we go ahead and kill this and do func pack, and we'll just go ahead and run it with help so you can see the commands that are offered here. We go ahead, you can see that essentially what it wants is the directory when you run func pack, but we have all those other options. In the kind of sake of time here, I'm just going to show you what it means to do when we go ahead and do copy to output. So normally when we do func pack, we'd run, and you see here that these function.json files actually got modified. So we have this original entry point, original script file, which are essentially the defaults that we just assumed for you. And then we have the script file and entry point here, which are the new .funcpack index.js. And this is, of course, the web-packed version with all the comments and whatnot inside of there that you didn't write all that stuff up front, but this is all the code that we determined you actually wanted when we went through there and dived down your tree of your dependencies. The problem with this, of course, is when you look at your Git history, now I've touched all these functions.jsons. Even if I were to ignore the stuff in the .funcpack folder, all these function.jsons here, got modified, and that's not necessarily very pleasant. So what you had to do before was you had to do func pack unpack period, and this still works because I'm still using the 1.0 library, so that functionality still is there. We didn't change any of your previous behaviors. When you go ahead and you look at the changes, the only changes that we really did there was some formatting stuff, and we do have the script file pieces here still, but this was essentially how you'd remove it. So actually, func pack and unpacked, you could now check in your unpacked version. But the problem is this still touched your JSON. Even when I do unpack, you see that there's changes. Mm-hmm. And so what we want to be able to do is never do that in the first place. So we can go ahead and do func pack. And if we go back and we have the help up there, the option copy to output there. What that essentially does is it flags to us, go ahead and copy all those function.jsons over to .funcpack instead. So don't touch my function.jsons. Go ahead and copy and add your own new ones is what it's telling us. So with that flag, we go ahead and we run this now. And you see, if we go and look at this, that we didn't end up changing the function.json in people anymore. It just has the original unpacked modifications. But if we look inside of funcpack, we now have all these directories that we didn't have in there before with the old model. And when we look inside of people, there's the function.json that has the modification pieces. The nice thing is I can now go ahead and delete funcpack, and you'll never know that I'd actually run funcpack on this library at all, which means I don't have to go ahead and ever delete or undo any of the changes that the tool did. And the nice thing is I can go ahead and do func Azure function publish from the .funcpack directory now, and everything will just work with no node modules actually being uploaded to Azure, which means your upload time is lightning fast.
Yeah. So do you just git ignore .funcpack on all of your projects?
Yeah, so essentially the recommended path there now is to use the copy to output flag, and then you add .funcpack to your git ignore, and then you should never see any changes from the funcpack tool show up in your Git history, which is what we know people would rather have. It's it's kind of awkward to have to change your config based off of what funcpack does to it. We'd prefer that we don't touch it at all. So that's the output. The other thing that's really interesting is the problem with this is if you ever made changes when you're using funcpack, you had to unpack and then edit and then go back and try you're running your host again. Well, the nice thing is that we now have the let's see, my remote desktop connection might have just decided to blip out on me, which is the danger of doing this via remote desktop, but it's back now. Funcpack, and then you can use -- watch, and then this will actually watch for changes for me automatically. So if I go back here and I make a change here, I'm just going to add another context.log statement because that won't break anything. And And yes, John, I know I'm using double quotes here when you're using single quotes. That's fine. But when I do that, it'll actually go ahead and detect that file change automatically for me using watch, and it will just re-update everything for me. So I should be able to go ahead and, you know, open up another one of these windows here. And when I run this, it should actually have the hello message in there, even though I didn't run funcpack again. I just have that watch statement. When I go ahead and call this API, we should be able to see hello world there in our logs. So we didn't have to go ahead and run funcpack again. It'll now go ahead and automatically see changes. Just to go ahead and make sure that you caught that, I can go ahead and add exclamation points in there. This thing should detect that there are some changes. You see here that we see people, allegiances, plants, films changed. And then I can go ahead and refresh. And we get hello world with exclamation marks. So now I don't actually have to keep on repacking, unpacking, repacking, unpacking. It's just a nice, simple flow of adding the watch statement and editing your code. And that way, the nice thing is that you don't necessarily need to pack your code when you're running locally, because your local disk is generally pretty performant and you don't need to worry about cold start as much. Yeah. But if anything should break during Webpack, because Webpack is a kind of sensitive thing, like if you treat it wrong, it'll punish you. You can actually have it being tested while you're editing your code, which is a really nice feature.
Oh, awesome.
After that, the other thing that I wanted to talk about here was language support. This is actually, for those of you who've watched this, the webcast and remember me, I used to be one of the PMs for Functions, believe it or not.
Oh.
And
then there was a terrible accident.
Yeah. What ended up happening was I really wanted to go ahead and spend a lot of time focusing on making the language experiences work really well. Something I was very passionate about, and just kind of wanted to, you know, mix things up. And so what I've spent the last 4 odd months, I forget how long it's been, working on is trying to keep on advancing all the language support stuff we've been working on for the last year or so. Previously, I did that as a PM, but now I'm just doing it by writing code every day, most days. So essentially the state of things today is in V1, Node.js, and .NET, that's C# and F# have full support. But we left a lot of problems that we were kind of in a weird position as not being able to fully address. Experimental languages were not easy to iterate on, so we were left in this position where we couldn't bring the full support without essentially breaking people in ways that we didn't feel comfortable doing. We had people using PowerShell and Python in production-like ways, in a way that we couldn't give them full support, and we didn't want to break them either. So we were just kind of between a rock and a hard place in V1 there. The versions for most of these things were oftentimes hard-coded in terms of our infrastructure. And so like Node.js is still stuck on 6.11.1, even though there's now Node 8 out, and Node 10 is around the corner. And the real thing that we learned here was that we were introducing functionality for a lot of these languages just because it was kind of cool to add languages, but we didn't think through the whole supportability story for some of these things. You know, can oftentimes blame me for not thinking through that as in the excitement of releasing a new service. So now in V2, we're here to kind of right some of those wrongs. Node.js, .NET, and Java are in beta support, as is V2 in general. Python is actually in development, and I'll share a link at the end for where you can actually watch and contribute to the Python conversation. And PowerShell is about to start design here in the next week or so. All languages will be able to be independently versioned without major version changes of the platform, which means that once Node 10 is out in April, I think is what they announced as the date, we'll actually have that support in a week or two after that's announced. That also means that we can go ahead and have different versions of Python. If there's a Python 4, there's PowerShell like 6 core and PowerShell 5. We'll go ahead and be able to have support for all those languages without dramatic changes to how the runtime actually works. And the goal there is to be able to keep on iterating on languages without breaking users as dramatically as we would have had to in V1. Yeah. So how the new languages will roll out, and this is a disclaimer, this is just current plans. They might change as we meet the reality of the world, but this is what we've kind of mapped out together. And most of this is using the Python as the example, because Python's currently top of mind for how do we actually get it up for private preview and public preview, et cetera. And we don't actually have private preview because we're open source, so I'm just calling it alpha and beta from now on. So alpha for Python is essentially, once we have a working functional version, we'll basically get a Docker container that has the Python version inside of it, and users will be able to go ahead and go build their own custom version of our host with the Python worker in it and deploy it via Docker. The nice thing about that is that means that anyone will be able to try it, but it won't have official support. So we'll basically have something which tells our support team, you're not required to give support for this, refer them to the forums. We really don't want people trying to use this for production purposes at this time, but we still want to be open, so we kind of in between those things. Once the quality bar is met there and we feel like we actually can start to support it officially, that's when we go to beta. And we know that once we release something in beta, which has portal support and CLI support, people will start to use it for something which might end up in production. This is something that we've learned, that even if we say don't, people will. So we're just going to have that be our bar, that this thing could go to production with pretty high confidence. You can think of it as like a release candidate in the kind of old terminology for some things. Things that aren't services, which is a weird thing. So once that bar is then met, it'll then GA based off of quality levels. So we want to make sure that it doesn't have any worse cold start than any of the other languages. We want to make sure that it performs well at scale. We want to make sure that we have the right supportability documentation and help to make sure that we can support various, like, this dependency X doesn't work. We need to make sure that that stuff is actually trained within our support teams as well. So that's essentially the 3 stages. There's nothing surprising there, but it's really just kind of our mindset that beta is really going to be much closer to people wanting to use it in production. And so we're going to be keeping it in alpha with very strict messages of this won't be supported. Like, I'll break you anytime I want to for alpha, just because we want to have the freedom to basically iterate fast during alpha. And then we'll go to beta once we think we're done iterating quickly. And then long-term visions, we want to be able to have more specialized environments for given frameworks and scenarios. This means coming out of the box with the dependencies you might need when you're doing portal development. Right now, you have to go ahead and run npm install yourself. And it's nice that you can do that in the portal, but we'd like it that, like, request.js is installed out of the box and things along those lines. Azure SDK isn't installed out of the box today. We'd like to have that out of the box as well. And we'd also like to provide more specialized environments for IoT, different tools that you'd expect to work inside of IoT environments. We can have those in some more specialized images. Those are options for us, not necessarily committed, just things that we'd like to go and investigate. We'd also like to investigate having official support for community-driven languages. The way that we've implemented the new language providers, it's relatively easy for anyone out there who has a fun weekend ahead of them to go ahead and basically implement our gRPC and protobuf protocol. And then they have to write a JSON file, and then suddenly it'll start working. The challenge is that we know that we can't support that without having a story around how to, like, what are the quality bars for those community-driven projects. And while we're still determining our quality bars for our first-party projects, that's kind of out of scope for the time being. But long-term, we'd really like to see it so that we can have community contributing to this, especially since Functions runs not just on Azure, but runs elsewhere. We'd like the community to be a part of expanding this to communities that we might not otherwise target, like just using Rust as an example, something that we don't get a lot of requests for, but I could see how someone who's passionate in the Rust community would want support for it. Or Swift. There we go. I said it on air, Matthew. Yeah. If you want Swift support for Functions, harass Matthew Henderson relentlessly. And then lastly, I just want to make the very strong assertion that we're trying to work entirely in the public. We kind of had some back and forth about whether or not we'd like the marketing splash of having our new languages be surprises on people. But we know that we get better quality when we get more user feedback, and being public is the right way to get user feedback. So everything that we're doing now, you can just kind of see on GitHub. We've got the Python worker there as that second option. You can actually see our detailed kind of design spec on how language extensibility works there on the second link. And then the third link is actually instructions on how to write your own. And I have it there spelled out, so that way there's a screenshot of it. I cannot stress enough how this is not officially supported in Azure Functions yet. Do not get me in trouble and file support tickets for your own custom language providers. I will have to pull this feature out if it starts resulting in support calls. So do not do it, or it'll make my life hard. So I'm asking personally, please don't do this.
And we'll post this in the notes after the webcast.
This will hurt my end of the year bonus from Paul if we end up having support cases from languages. So if you have any actual feedback, be sure to mention Asabri, Pragna, or myself on this. All 3 of us working on this full time. So would really appreciate any of your feedback. You can get it all. So yeah, let's pop back to.
Chris, you want to talk about some people's questions?
Yeah, let's go through some questions.
We have been tweeted extensively asking about all sorts of different functions, functionality.
Mm-hmm.
All right, cool. So right off the bat, we have a question from Justin Yu about using Key Vault to store App Insight's instrumentation keys and storage account connection strings instead of the current environment variable solution. And we want to let you know that we are working on Key Vault support. It's going to be coming a little bit later. We'll hopefully have a preview out at some point. But yeah, right now the app settings are the best way to store that. And they are encrypted at rest, and we're very, very confident in the security of app settings, which is why we store everything in them by default.
Yeah, the biggest downside of that option is essentially not having the central management of all those things, and we really realize that. But definitely from a security perspective, besides the fact that without ease of management, you might end up missing rotating things. From a cryptographic point of view, I'll say we feel pretty confident in how secure that is. But you should still, if you're trying to follow best practices, have your secrets in Key Vault and then have that as part of your deployment step to update those things. So it's still never actually, sitting anywhere unencrypted on any machines.
Yeah, because you can't write a big ARM script, right, to update all of those app settings across all your different functions. Yeah. All right, the next question is from Chris. I don't know if Chris has a last name, but it's a different Chris than here. And they asked how to fix a broken API definition, specifically how to revert it back to its initial state. And this is good. This is kind of my baby feature. And in the portal, there's a big generate open API definition button. And I guess it's apparently not super duper clear, but that does revert it back to the initial state, kind of pull all of the info back from your function.jsons. And then repopulate that into the portal. And so then you can make changes and save them back again. Let's see here. Yeah, you've already covered language support. Somebody called Albalogic asked about language support. There's a bunch of different API questions.
Can you comment on both F# precompiled and TypeScript?
Yeah, so TypeScript is an interesting thing, and it's one of those things I'd like to get more feedback on. In V1, most people wouldn't know, but if you paid attention, you'd see we did support giving us TypeScript files, .ts files, and we would detect that was the case and go ahead and run TypeScript compile for you and cache the results and try to detect changes. The problem was it was relatively flimsy of the implementation. There was quite a few bugs we still had to work out. There was cold start implications, and you couldn't control the configuration of the TypeScript compile itself, which meant that you had to use our defaults. And so in general, it didn't end up with anything which was usable for the scenarios, like the more complex scenarios for TypeScript, which is really where TypeScript comes into play over JavaScript. And so you end up having a better experience doing TypeScript build locally and then pushing your JavaScript out. So in V2, I made the call to not support TypeScript in that, just because I wanted to, reduce how much stuff we actually did have to support and make sure that what we were supporting was giving good customer value. If you still think there's good use cases for us supporting TypeScript as a native language, I'd love to hear them. But for the most part, I didn't see it being useful for larger complex applications, which once again, that's where I see TypeScript being useful. And so we didn't want to lead people down the wrong path of building their TypeScript in this more strict sense and not using the full functionality of TypeScript. We do have some other cooler ideas around TypeScript that we'll probably, kind of start, peeking out and releasing. But they all generally revolve around local tooling, not server-side compilation of TypeScript. F# script.
And Fabio took that one on the chat window.
Great.
So
thank you, Fabio.
Move on to the next.
For the purpose of the recording, go ahead and read out. So F# is precompiled, technically supported today. F# workloads can be tested and deployed using Visual Studio. The F# team is helping with tooling and template enhancements to make this first class. Yeah. So also, can you actually switch the camera, because right now it's a screen share of
it's just that's awesome,
which is driving me insane.
For everybody on the webcast, it's just so you know,
it literally says that I'm presenting from the camera right now. Can you try doing it? Maybe my machine just isn't working.
Let's.
Yeah, it says stop presenting.
Yeah, looks like it. We'll see. Also, for the purposes of everybody on the live stream, we have like 2/3 of the Function PM team just here in the room, off camera. They're great. They're our good support staff, all our PAs. Yeah, perfect. See, we're doing it. So here, let's see here. We have a couple of different questions. Chris, can you talk a little bit about our plan for dependency injection?
Yeah, so dependency injection is something which is really close to my heart. In fact, since Fabio's watching this, that means he might not be working on DI, so we can get back to work. But seriously, so what we're doing is we're moving and following the ASP.NET DI story. So I think it's like service containers, something like that. I don't know. I don't know the actual interfaces very well myself, but I know that essentially the model is that we're going to be moving all of our internal stuff onto using DI, and then there'll be a second stage where we then expose those DI options to users of C#. So that's essentially the two-stage models. We'll be moving ourselves in V2 onto kind of a full ASP.NET DI story, and then we'll be walking through, once that's done, how to expose some of the same functionality to users. So it's, unfortunately that means that it's still not super close, but it's definitely close in the sense that the support for us is now starting to roll out. Fabio has a PR that I think is out right now, or he's getting ready to send for internal support. And then we have to go ahead and onboard all the different services that aren't using that DI to that DI. And once that's done, we'll start design on the user functionality of it. But it's definitely in scope for V2, as I understand it. I'm looking at the PMs actually, because you guys should know. But we do plan on having DI support in V2. So I mean, granted, that's some date in the future, but it means that it will be before V2 GAs, which means that it will be there for the next version. This isn't something we'll keep on kicking down the road. We know it's important.
Yeah. Cool. Thank you, Sladeep, for that question. We got a question from Luke Gusso about HTTP versioning, specifically what our best practices are and how to handle any of that custom routing. And at the moment, we have a preview of slots to handle code versioning, but we're looking to change that around a lot before it goes GA. At the moment, for HTTP versioning, I'd recommend you use proxies, but at the moment, since we don't have like an official pre-canned solution, you can use proxies or API management to do any of the different versioning schemes that you'd want. One of the coolest implementations I've seen is just deploying different versions to totally different function apps and having a proxy that takes like your API /v1.0 to your first function app, and then you deploy all of your new code to an entirely new function app that then proxies to like v1.1. And if you're on the consumption billing model, that solution ends up working out perfectly, because as you move traffic from your old code to your new code, your billing moves along with that traffic, and you don't have to worry about paying for the 5 different versions of your function app that you have as you add, or whatever the n+1 version of your function app.
The thing that I also like about that model is if you do decide later on that you want more complex version management, like what API management would offer, it's really easy to then move to that model, because you essentially replace that proxy with API management.
Yeah, exactly. Cool.
And if you haven't looked at API management, they just GA'd their API versioning support. It's really, really nicely thought out. Like, great job to the API management team for that. It was a pleasure to read that blog post.
Yeah, absolutely. Do you have this list of questions up, Chris?
No.
We have, so here we have a question from...
do the Mo. Yeah, Mo.
Yeah, do you want to talk about this a little bit?
Yeah, so Mo asks, why does it cost so much for storage when they're using functions? Oftentimes storage costs more than their actual functions bill. I can tell you why, and it's because you haven't swapped app insights yet. We use storage for a variety of different reasons. We use them for basically doing some leases, but that's a relatively small amount. If you're using certain triggers, we end up using storage for internal queues. Generally, if you're using the blob trigger, that's the biggest reason we're using internal queues for blob trigger. But also the event grid integration is also using storage queues under the covers now in the latest release. But one of the things that actually introduces a lot of costs ends up being all of the logs. If you don't turn on App Insights and disable your storage dashboard setting, it will keep on logging to storage dashboard. This is something that we need to give another kind of strong push to get rid of the storage-based logging. We've talked about in V2 actually removing that entirely, and in V1 just constantly. We already yell at you to turn on App Insights in V1, but we should probably continue to yell at you to turn off your storage settings.
Yeah.
Essentially, App Insights is the answer there for helping to reduce the cost of how much stuff we're logging out to storage. And the nice thing is that App Insights is also better than our storage-based implementation for logging. And so it's a win-win. It will cost you less, and it will be more useful. So definitely recommend that you look at, you've gone ahead and made your Azure Web Jobs storage dashboard setting,
Yeah.
an empty string, and that will really help.
Yeah, and an interesting note, App Insights also charges you for the data ingress. So a lot of the times, if you leave everything at the default, you'll be just moving from paying a lot of storage per execution to paying a lot of App Insights for execution. And so we have a whole request sampler and request aggregator function that you can configure with application settings. They're already pretty nice by default, but if you're really getting slammed with logging costs, you can really ratchet up that sampler so that you're sampling, one request every 10 seconds or something.
Yeah.
And sending like almost no info to App Insights.
And it's also important that if you really don't want to have logs, make sure that you only collect error level logs. Like if you have it set to trace, you're probably going to be paying some storage costs at high loads. So the nice thing with the App Insights integration, like you said, is that you have knobs. If you want to get everything in the world and you're willing to pay for it from App Insights, you can. If you want to have basically just sit under the free limit, up to a certain scale, you can basically pay nothing for App Insights. Above a certain scale, even at just the minimal amount of logs, you might still end up paying. But that's way better still than the storage option where you had no control over those knobs. And so you were getting all the logs or no logs.
Yep. All right, I think we have about time for one more question. If you want to scroll through the list, we can talk about cores. We can talk about different precompiled languages.
So I saw one at the bottom there about iLogger. Azure Functions CLI doesn't capture logs written in iLogger.
Yeah.
When will it be figured out? So that sounds like something which I'm guessing there's like a GitHub bug for it open already. If this is V1, some of the problems were ended up being that when we introduced the iLogger pipeline in V1, not everything worked with the trace writer. So there might still be some kind of misses there in the iLogger pipeline. In V2, we've moved everything over to iLogger, and in the V2 CLI, we have confirmed that everything is getting logged and not missed. So we might need to have an open GitHub issue for that if it's not already open, Justin. Definitely you can ping me on Twitter or whatever if you want, and I'll see if Ahmed has any updated status on if there's an open CLI issue for that. Otherwise, in V2, I know that we've done the right things to hopefully make this work. So hopefully it's a V1 issue, not V2. Let me know.
All right, that sounds good. Thank you so much for everybody that wrote in feedback on Twitter. We had a lot of fun this morning sitting through all of the feedback and reading all of it. The next webcast is about this time next month on the 8th of March.
So definitely make sure that you kind of tune in next month. If you have any questions, you can go ahead and keep them coming on Twitter. We answer questions all throughout the month, but it's always nice to do them in a video form. Be sure to keep an eye on our GitHub if you want to keep an eye on what we're actually working on day to day. We always love getting user feedback.
If there's something that you want prioritized higher, we have a user voice where you can vote on different feature requests that we may not necessarily be working on right now. That's a lot of the kind of inspiration we take to when we're looking to make new prioritization decisions.
Cool. Well, thanks everyone.
Thanks so much for tuning in.
Have a good month.
Bye.